The statistical tests and methods that we've looked at so far are called parametric tests. These are the tests that we use when data are interval or ratio scaled, things like age, number of asthma attacks, things where we can put numerical values to them. But quite often we have categorical data. For example, have you had a treatment? Yes or no. Have you taken a medicine? Yes, you know. Has your health improved? Yes or no. So categorical data are very common, and there are slightly different techniques called non-parametric statistics that we're going to look at. So we'll begin by looking at the simplest situation that you could encounter, that is analysing two categorical data variables. So if we want to look at the relationship between two categorical variables, we can't use things like the mean or similar statistics because it doesn't make sense in that situation. So we're going to use an example that Andy Field uses in his book, and he imagines a situation where a researcher was interested in whether animals can be trained to dance. So he takes 200 cats and tries to train them to line dance by giving them either food or affection as a reward for their behaviour. And at the end of the week, he counts how many animals could dance and how many could not dance. So there are two categorical variables here. There's training. The animal was trained using either food or affection, not both, and danced. Did they learn to line dance or did they not? So by combining these categories, we end up with four categories, and that's what we're going to look at next. So we're going to begin by opening a new file, which is File, Open Data, and the file that we're going to look at is called cats. So we'll open that file. Very simple file with two variables, training and dance. Two values for each one. We've got food as reward and affection as reward, and we've got dance yes and dance no. If we switch over to the variable view, we can see the variables and their labels. So you could have food as a reward or affection as a reward and dance yes or dance no. So to analyze this data, we're going to go back to analyze, do descriptive statistics, and this time from the menu we're going to choose crosstabs. So the thing that's doing the predicting is the training, so we're going to put that in the rows, and then the dance, we're going to put that in the column. The cells is quite an important one here. Now the one that I always choose is row, because we're really interested in the difference between the rows. This will become clearer when we look at the table, so we say OK to that. The statistics, there are various statistics which just depend slightly on different circumstances. The only one that we really need to look at just now is the chi-squared. So we'll say OK to that, and we will run the test. Okay, what we get is this table here to begin with. So let's just have a look at this table. What this table shows us is the type of training. So we can see food as a reward, affection as a reward. We can see they have values of 0 and 1, but they're just labels. There's no progression from 0 to 1. And we can see that where they got food as a reward, 73.7% of the cats did dance, 26% didn't. However, if they received affection as a reward, only 29% danced and 70% didn't. So there is a big difference between the two groups. And if we look down to the statistics, we can see the Pearson chi-squared value is 25.3. The significance level is less than 0.001, which SPSS just indicates by writing 0.000. So in summary, when food was used as a reward, most cats would dance, but when affection was used, most cats wouldn't dance. So what the chi-squared statistics is doing is seeing whether the two variables are independent of each other. If the significance value is small enough, then we reject the hypothesis that the variables are independent and accept that the hypothesis is that the variables are in some way related. So we can see that in this case the variables are related. The value of the chi-squared test, as we can see, is 25.3, and this is highly significant, indicating that type of training has a significant effect on whether an animal would or wouldn't dance. Another useful feature of the crosstab procedure is that it can generate odds ratios and relative risks. These are two terms that you will see reported in many papers. Rather than try to explain them, which I do in the workbook, I'm just going to demonstrate them here. So we'll go into Analyze, Descriptive Statistics, crosstabs, same as before, we have training and dance. In the Statistics button, we have chi-squared, which we've looked at, and this time we're going to look at risks. So I'm going to do Continue, and I'm going to say OK. So we see the crosstab here, which we've looked at before. We see the chi-squared test. This time we're going to look at the risk estimate box shown below. It's not exactly clear what is shown here, so I'm just going to explain it. So you see the top line says odds ratio, which is fine. We'll explain that in a minute. The other ones say, for cohort, did they dance? Yes. And for cohort, did they dance? No. These are relative risk measures. So what are these numbers? 2.487 and 0.374. So the way that they're computed is if we go back up to the crosstab here, to get the relative risk for whether they danced, we divide 28 by 38. In other words, those who danced yes as a proportion of all responses, divided by those who danced for the other outcome, the other predictor variable, which is affection as a reward. And when we do that, we divide that by that, that by that, and then divide one by the other, we get 2.487. Alternatively, we could look at did they not dance, in which we look at 10 divided by 38 divided by 114 divided by 162. Take the ratio of that, and we get 0.374. So given these results, we can estimate that a cat rewarded with food is 2.49 times as likely to dance. In other words, that represents an increase of 149%, as a cat rewarded with affection, or 0.37 times likely not to dance. In other words, 63% less likely to dance. So the way that we get relative risk depends on which outcome we're looking at. Some references will advise recoding the data so that the relative risk is always greater than 1. However, it's important to take into the consideration the message that you want to deliver. In the above example, for example, it might make sense to drive home the message that cats who are not given food as a reward are 63% less likely to dance. If we go back to the odds ratio data, we can see that the number is 6.65. So what the odds ratio represents is the odds of an event or the event occurring dancing to the probability the event does not occur. And you can see that number is significantly higher than the relative risk, and that is because it's computed in a slightly different way. So for the odds ratio, we're looking at the odds of 28 divided by 10. In other words, we're comparing one outcome versus another, and we do the same for the other one. Again, in the workbook, I show how this is calculated. So the odds ratio and the relative risk are not exactly the same. They both show, however, an increased probability that the cats will dance, giving food as a reward. And the final advantage of the odds ratio is it doesn't vary like the odds ratio depending on what outcome you use. So sometimes that's why it's favoured in studies. So that's really what I wanted to say about the crosstab procedure, which is a very common procedure when you have data that's organised like this and the kinds of things that you can do using SPSS.